Alright, this is video 7.3. We're going to be analyzing units today. This is a video that comes in very handy for your science classes. There's a lot of math and science interchange because of this is something that you'll use a lot when you are doing your upper level sciences. Sometimes you'll need to be able to convert between units, and that's what we'll be learning how to do today using algebra. Before we get started, I just want to remind you of a couple of things. All right, so we could say that 1 is equal to 1. Would you agree to that? If we take our 1 and we divide it by 1, what do we get? We get a 1. Right? That equals 1. So if you put two quantities equal to one another, and you were to divide those quantities by each other, because they are equal to one another, you're going to get a 1. Another example would be 3 is equal to 3, and 3 divided by 3 is equal to 1, right? So we're going to take that idea and use units in it. So if 1 foot is equal to 12 inches, which we know that it is, okay, then we can take that 1 foot and we can divide it by 12 inches, or the other way around, we can say 12 inches divided by 1 foot. What do all of those equal to? They have to be equal to 1 because we are dividing a number basically by itself, right? So 3 divided by 3 is 1. So 1 foot divided by 12 inches, because 1 foot and 12 inches are the same thing, is going to be equal to 1. Now, why is that important? If we take any given quantity, let's say a 5, and we multiply it by a 1, what do we get? We get a 5. We're going to use both of those ideas in converting units. There's one other thing I want to remind you that you know how to do before we move on. All right, we've already learned how to multiply fractions. Just going to remind you. When you multiply fractions, like 1/2 times 3/4, what you're really doing is you're making one singular problem in the middle. 1 times 3, you multiply across the top and get 3. 2 times 4, you multiply across the bottom and get 8, right? If you have a fraction where your opposite sides are the same number, they cancel, right? So we could write this as 1 times 2 over 2 times 3. That 2 on the top and the 2 on the bottom are going to cancel out, and that would leave us with 1/3. So we're going to use the idea of making two things that are equivalent, making them into a fraction that equals 1, and multiplying fractions. So let's get started. The vocabulary that you need to know for today is called a conversion factor. That is, if we take two quantities that are equal, like 1 foot and 12 inches, and we put them together, we can call that a ratio. So 1 foot to 12 inches, or 12 inches to 1 foot. That is a ratio of equal quantities, and so that is called a conversion factor. That is what you will use when we are doing our conversions here in just a minute. So let's use some conversion factors to solve some problems. We are going to, when we do this, you're going to be given a certain rate, and I want you to take that rate and write it as a fraction. So remember, a rate is two quantities that have different units, and we'll write it as a fraction. And then we are going to multiply that fraction by a conversion factor. And we're going to set it up so that our units, one will be on top and one will be on bottom, so that they'll cancel. Just like when we had that 1/2 times 2/3 and our 2's cancel, we are going to do that same thing with our units so that the units will cancel out, leaving us with what we want. Okay, so we'll cancel our units, we'll multiply, and then we'll reduce. So let's say we wanted to know how many inches are in 100 feet, okay? So what we're going to do is we're going to take our given rate and write it as a fraction. So we have 100 feet. We're going to put this over inches. We don't know how many inches, but those are equal to each other, so we can write them as a fraction, one on top of the other. Okay, I'm going to multiply by my conversion factor. Here's my conversion factor right here. I need to write my conversion factor so that my feet disappear, because I want to end with inches. I don't want to have feet at all. So if my feet are on top here, I need to write my feet on the bottom down here. So I'm going to multiply my 1 foot down here and multiply my 12 inches up there. Okay? So this is a rate, and this is the conversion factor. I'm going to multiply those two fractions together, so I'm going to put them across one single line. I want my feet on the top here and my feet on the bottom there, right? So then when I multiply, I'm going to do 100. I'm going to multiply across the top and multiply across the bottom. 100 times 12 is going to give me 1200. And on the bottom, there isn't a number here, so times 1 is just going to be a 1, right? My feet go away, and that leaves me with inches, so I will have 1200 inches, right? Now that's a simplified version of what we're going to be doing in the book, because in the book, the inches would cancel out because we would end up reducing everything. Let's try some for real examples that'll be like what you have for your homework and on in the quiz and on the paper we'll do in class. Okay, the average American eats 23 pounds of pizza per year. Okay, so that right there is our rate. We have 23 pounds in 1 year. Find the number of ounces of pizza the average American eats per year. All right, so we are wanting to change our pounds into ounces. So we need to know, how do pounds and ounces relate to each other? So how many pounds is an ounce? All right, so 1 pound is how many ounces? 1 pound is equal to 16 ounces. So that is going to be our conversion rate that we're going to use. So I'm going to multiply here. I need my pounds to be on the bottom, so I'm going to do 1 pound, and I'm going to do my 16 ounces on the top. My pounds are going to cancel, and that will leave me with ounces per year. So remember, I'm going to multiply across the top, multiply across the bottom. 23 times 16 is 368, and so then that would be ounces per year. Okay, let's try another one. A strobe light can be used, a strobe lamp can be used to measure the speed of an object. The lamp flashes every 1/1000th of a second, and the camera records the object. The camera records it moving at 7.5 centimeters between flashes, so how fast is it moving in meters per second? So it's a little confusing. We have our seconds here, so we're going to use that, but we have centimeters, and we're going to be changing that to meters, right? So let's go ahead and use our rate, which is going to be distance over time. That's what it gives. We want meters per second is what we're looking for, all right? So if it moves 7.5 centimeters for every 1/1000th of a second, all right, that would be our rate right there. So let's go ahead and get rid of our fraction. So if we were going to simplify this fraction, remember, if you're dividing by a fraction, if we had 1/2 divided by 2/3, we would keep, change, flip. So we would do 1/2 times 3/2. So that's the same thing right here. We're going to write this as 7.5. If we wrote it this way, 7.5 divided by 1/1000th, we would keep, change, flip. We would do 7.5 times 1,000, right, which is going to give us 7,500 centimeters per second. So that's what I'm going to use. Right? Now I want to convert my centimeters to meters. So how many centimeters are in a meter? Well, 1 meter is equal to 100 centimeters, right? So that's what I'm going to put down here. I need my centimeters to be on the bottom. So I'm going to put my 100 centimeters. That way my units will cancel. And my 1 meter on the top. So I'm going to multiply across the top. 7,500 times 1 is 7,500. And then 1 times 100 is 100. Now I need to divide my top by my bottom, which is going to give me 75 meters per second. We're going to do one more. I know these are super duper confusing, but we're going to do one more, and I promise we'll do more practice, and then you'll get better at it when you're doing it in 8th grade science, because you'll do lots of these at the beginning of your 8th grade year in science. So the rate of 1 knot is equal to 1 nautical mile per hour. All right. Now, 1 nautical mile is 1,852 meters. So that's the information you're going to need for multiplying around in here. Most of the time we don't really use nautical miles or meters or knots when we're using everyday terminology. That's why I'm giving you all the information. So what is the speed in meters per second of a ship traveling at 20 knots? All right, so if it's going 20 knots, then we know it is going 20 nautical miles. And we know that it's miles per hour. Sorry, that should be MI. So we're going to set up our units in order to get meters per second instead of miles per hour. So we're going to be changing our miles and our hours in it. All right? So this is what we're going to be using. So what we're going to want to do, we're going to have our 20, instead of writing nautical, I'm just going to do that, miles per hour. All right? We want to change our nautical miles to meters, and we know that 1 nautical mile is 1,852 meters. So I'm going to write it this way. So 1 nautical mile is 1,852 meters. So that's going to give me my meters. My nautical miles will cancel. That leaves me with my meters on top. Now I need to change my hours into seconds. And I can tell you, just because I have it memorized, on a worksheet or on a test, I will give you what you need for your units. I know that 1 hour is equal to 3,600 seconds. All right. That makes my hours disappear. What I'm left with is meters per second, so that's good. So I'm going to multiply across the top. So that's going to be a 0. Right, so 20 times 1852 is 37,040 meters for every 3,600 seconds. So I'm going to divide 37,040 by 3,600. So 37,040 divided by 3,600 seconds gives me approximately 10.29 meters per second. That's a lot. That's really fast. All right, so there is homework tonight on your quiz. Go ahead and click on it and work on it. Do the best that you can, and we will practice some more in class.